Hello, Alberta teachers. It's Gord here. And today we have a brand new puzzle. It's called Ups and Downs. We start off with a loop. In this case, we're going to start with a loop of 5 integers. There we go. And where does this 5 integers, where do they go next? Well, they're going to go to another loop of 5. And let's look at the algorithm. The algorithm is as follows. We take the blue, for example, the blue 5 at the top. We look at the purple 6 and the green 6. We look at the difference. 6 minus 6, it's 0. So we look at 5 plus or minus 0. Oh, it's just 5. So nothing exciting there. The blue stays at 5. Let's look at the green now. So the green is 6, and then we're having a blue and an orange. 8 minus 5, that is 3. We always take the largest minus the smallest. 8 minus 5 is 3. Then we take 6 plus or minus 3. We always want to be as small as possible without going negative. So 6 plus 3, no. 6 minus 3, that's what we want, smaller. And so that's going to be 6 minus 3 is 3. Okay, let's do the orange one. So you guys do it. Okay, it is green 6 minus red 4. That is 6 minus 4, that's 2. So 8 plus 2 or 8 minus 2. What's closer to 0 without going negative? It's obviously 8 minus 2, which is 6. So we can keep on doing that all the way around, and we get our new loop. What do you think we do then? Of course, we go for another iteration. And what happens here? Well, let's look at the blue at the top. That is 5 minus 3. So we have the purple 5, the green 3. And we have, that's 2. So that means we have 5 plus or minus 2. Well, 5 minus 2 is closer to 0 and without going negative. So we have 3. And we can do that all the way around. Same thing again. And that's the result that we get. What do we do now? Well, the same thing again. So we keep on doing this again and again and again. And let's just see that in this case, just take a moment and make sure that you agree that everything here is correct. For example, the red 4, that new red 4, where did that come from? Well, look at the previous one. We have the orange 5 and the purple 2 beside the 1. 5 minus 2 is 3. So we have 1 plus or minus 3. Well, 1 minus 3 would be negative 2. We never go to negatives in this entire puzzle. So you can toss that out. So we're going to go to 1 plus 3, which is 4. That's why we have the red 4 there. We are going to keep on iterating and keep on iterating and keep on iterating and see what the heck happens. And if you do that, this is the result. Now, if you choose some other pattern, you might end up with things getting really, really nasty. So maybe for this first experiment with your kids, you should maybe just choose one of these, this starting one that I've started with, 5, 6, 8, 4, 6, and then you're going to get this result. Let's look at another one of these ups and downs. Here we have 4 in a loop. Choose any 4 integers, and let's see what happens. If we do that, what's going to be the next step? Okay, well, it's going to be the same pattern, but we just are going to choose different integers. So that 5 at the top, what's going to happen with that? Well, 11 minus 3, those are purple 11 minus the green 3, that's going to be 8. So it's 5 plus 8 or 5 minus 8? What's it going to be? Well, of course, 5 minus 8 is negative. We don't touch that, so it's 5 plus 8. We're going to get to 13. Next, for the green, and we go all the way around, okay? And you can check this out up at your leisure. That's the result. And we can do it again. That's the result. And we can keep on going, and we get this crazy loop here. Okay? So, at any point, your students can start exploring this by themselves. Some of these explode, and that's just fascinating to see. And others, let's just see this one here. This one here doesn't explode, but I got tired solving it. Okay, so I started out with 7047740 in a 7 loop, and it kept on going. It went beyond this. Here's another set of 16 and another set of 16. So this was getting wearying, but I know from a computer program, I know that this ends in a giant loop of 112. So, who could have predicted that? This puzzle is not only great for mathematicians, it's also great for computer scientists. There are all sorts of fascinating patterns here. So enjoy, and for those budding computer scientists who want to program, yeah, let them in on this and see what they discover. Take care. Talk to you again. Bye-bye.